Question 4. The diagram below shows a metal rod free to roll across two parallel metal rails. The rails on the rod are in a magnetic field directed into the page. That's what the X's here illustrate. The ends of the rails are connected to a 12-volt power supply. State and explain what happens to the metal rod when the power supply is switched on. Well, the statement would say that it rolls, and I believe it rolls to the right. Explaining, you would have to say there is a force. There's a force acting on what's it called, the rod. So there's a force on the rod due to the current within it interacting with the magnetic field, B field, and the direction is according to the right hand slap rule, which we can try really quickly now here. So see, the positive side is here and the negative side is here. That means the current, conventional current, is flowing this way. So current is flowing down through the rod. That's the direction of your thumb on your right hand. The magnetic field is into the page, which is the direction of your fingers on your right hand. So the slap or the force will be this way. So you could explain the right hand slap rule in more detail if you'd like. B is to calculate the electromagnetic force experienced by the metal rod when the power supply is switched on. So the formula relating this is F equals B I L, where B is the magnetic field strength, which they give you here. I is the current travelling through, which they don't give you. Okay, but remember, you've got Ohm's law, I equals V over R, because they do give you the voltage of the power supply, and they do give you the resistance of the wires, rails and rod. So we can calculate I, because we have V and we have R, so we have I, so we have I here, we have B, which is given, and the only other thing we need is the length. And we've got to be careful here, because in our diagram the length that we actually have to use is the length that has current running down it, which is only this section here. Okay, if you use the full length of the rod, it's going to be wrong. You have to just use this length that is running through here. So you need the distance of separation of the metal rails as your length. So we're not using that, we're using the length of distance between the parallel metal rails. So if we plug all those numbers in, let's make it one big formula over here. So we'll substitute V equals R, it's going to be B V L over R, and we substitute all those numbers in to find a result. I'll just calculate it. 0.0, this is 5.3 305 times 10 to the negative 10 to the negative 5. The units are newtons, so it's quite a small force, but you probably would see this since it's rolling, so there's very little friction in the consideration of this. Now the answer is to two significant figures, because our limiting factor is this, which is the magnetic field strength, which is only to two significant figures. Multiplying and dividing, same as an earlier question.